13, 14, 15, we are doing square root multiplication. When we do square root multiplication, we could go ahead and multiply them first, but our numbers would be really huge. So what we want to do is simplify them first before we multiply so our numbers aren't so big. And so here I have 49 square root of 98. 98 is 49 times 2. Square root of 49 is 7. So 7 times 4 is 28, square root of 2. Then I have times the square root of 50. 50 is 25 times 2. Square root of 25 is 5, so I get 5 square root of 2. Now when I multiply square roots, I'm multiplying the front numbers together and the square roots together. So I'm going to start out by doing 28 times 5. 28 times 5 is 140. Then I have to take the square root of 2 times the square root of 2, which is the square root of 4. Once I get this far, I have to look at the square root and decide, can I simplify further? Well, in this case, I can because 4 is a perfect square. The square root of 4 is just the nice whole number 2, and so I have to take 140 times 2, which gives me 280. Now this one came out to a nice whole number. Again, if I grab my calculator and I did 4 square root of 98 times the square root of 50, sure enough my calculator says, oh yeah, it's supposed to be 280. Not all of them will come out to nice whole numbers, integers, but if they do, you can always double check with your calculator. Number 14, if I want to simplify that one then, I have 3 times the square root of 54. So I have to think about the biggest perfect square that divides evenly into 54. And 9 looks like it's the biggest perfect square. 9 times 6 is 54. I know that I can't do any bigger ones because 6 doesn't have any factors other than 1 that are perfect squares. Square root of 9 is 3, so 3 times 3 gives me 9, square root of 6. Then I have to times the square root of 48. 48, 16 times 3. Square root of 16 is 4, so I get 4 square root of 3. So in this one, I'm going to take 9 square root of 6 times 4 square root of 3. I'm taking the 9 times the 4, which is 36. The square root of 6 times the square root of 3, 6 times 3 is 18. 18 is not a perfect square, but I can simplify that because 18 does have a factor that is a perfect square. So I say, oh, this is 36. 18 is 9 times 2. The square root of 9 is 3. And so I have to take 36 times 3, 108. So I get 108 times the square root of 2. And now I've got my answer as simplified as I can get it. So number 15, if I'm going to simplify that one, square root of 50. 25 times 2, square root of 25 is 5, so I get 5 square root of 2. Times 4, square root of 12. 12, 4 times 3. Square root of 4 is 2, so I have 8 square root of 3. When I multiply those together, 5 times 8 is 40. Square root of 2 times the square root of 3 would be square root of 6. Now if I look at that, 6 is not a perfect square. 6 doesn't have any factors that are perfect squares other than 1. And so I can't do anything with that one. I just leave it just like it is. So we saw where you might get a nice whole number answer, where you get one that you can simplify after you multiply, and where you get one where you can't simplify. Again, if you really wanted to double check your answer, even though it's not going to come out to a nice whole number, if I use my calculator, square root of 50 times 4 square root of 12, I get 97.97, so forth and so on. If I put in 40 square root of 6 and hit equals, I should get that exact same number, 97.9795, and so forth and so on. And so to double check yourself, you can always put it in your calculator, see if you get the same decimal answer when you multiply the problem and when you put in the answer, and that way you kind of know you're on the right track.